before, we'll be going over some kind of important conceptual topics, like we did 2 weeks ago when we talked about variables. So this is something that'll be pretty important no matter what CAD environment you're in, whether it's Onshape or something else. It's kind of a big idea level of topic that we're going to discuss. And I spoiled it a bit last week, but that is going to be surfaces and reference geometry. So we have a few more people, which is good. I don't want them to miss too much of the beginning. So, all right, so I do want you to pull up Onshape just so you can follow along. To give you, I guess, a preview of the challenges this week, we'll have this thin-walled shape, maybe a bit familiar to something you've done before. Second one, polyhedra, also kind of on a theme, but this time with a bit more complexity, which you'll be able to do now after you learn this new trick, this new technique. And the third one is a banana, kind of like a pencil, but it's curved. So look forward to that. What we're going to be talking about is first reference geometry, and then surfaces, which in a sense are kind of a reference geometry. And so what is a reference geometry? Well, the geometry part is some object, whether representing a real object or more of an abstract kind of object, that gives you a sense of maybe direction or location. And so a prime example is this coordinate system that you start out with. Sorry, I've been having some problems with my mouse today. Might have to fix that. I'll work with my touchpad for now. Shoot. Yeah, so the coordinate planes, these are your reference geometry. Think of it like geometry that you learn in school. You learn your XYZ Cartesian geometry, and you have your origin. And the purpose of these is to define both a location and an orientation. So as we've seen before, you're able to make your own planes. The way we learned how to do that was with this plane button in the top here. And so just to show you what we've done before, how you know how to do this is you select the plane tool, you pick either a plane or a face, and you can just offset it. And so now I created my own reference geometry. I have another plane here that I can use, and I can make sketches on this and so on. So that's pretty good. I will show you one other way to do this, which is let's say that you're working with a part. And let's say now that I need to draw something in the middle of this part. And so motivation for that may be a bit hard to see, but perhaps we want to make maybe a hollow feature where we need to symmetrically extrude something in the middle of this. So what we want to do is make a sketch that's perfectly slicing, say, this block. And so the way we do that is we create a plane, and if you drop down where it says offset, we've had all these options all along. Say mid-plane, and the way that works, you select two parallel faces, kind of like the opposite faces of this block, and what it produces for you is the mid-plane. So the plane that is exactly the same distance from both of those faces, those selections. So that's another way to construct a plane. And I'll show one more, which is the line angle approach. So go to my plane tool again, and this time I'm going to do line angle. And so this one takes a line. So you need a line somewhere. Maybe it's a sketch, maybe it's an edge of a part. And you also specify an angle. So let's say it's 30 degrees. And you can see what happens here. What I get is a plane. It says I do need another reference there. So what I get is this plane, which is kind of at an angle. So what I specified is a line that exists somewhere, a reference from which to measure that angle, which is in my case, the front plane, and then a value for an angle. So 30 degrees, I can change it all I want. And when I accept this, what you'll see is I have this angled plane, and now I can create sketches here. And as before, I can kind of work off existing sketches. I'll get something like that. And you can see now what I've created is kind of an interesting shape where I have a rectangle and I have a triangle coming off of it at an angle. And so hopefully you start seeing some of the potential of this, of creating various planes and different orientations and locations in space. And what will really tie this together is the next thing, which is surfaces. And so as we introduce a surface, I want you to think about the classic cube that we started out with. And when you model a cube, just the way that we've been doing with an extrude from a sketch, conceptually what you're kind of getting is a solid object where the entire volume of the cube is being filled with matter, and that's your object, right? And so we're going to introduce now a different way to think about modeling things, which is the surface. So a surface is like just the outermost part. So it's in a sense two-dimensional. If you have like a body or a hand, the surface of your hand is kind of like just your skin. So you can imagine like your skin isn't solid. It's not like your hand is made out of skin all the way through, but just the outermost layer is made out of skin. So you can think of surfaces kind of like the skin of a part, where for a cube, for example, the surface of a cube is just those 6 rectangles, or 6 squares, perhaps. And another way to think about it maybe is just like a infinitesimally thin-walled object, right? And so that's kind of what a surface is. So just to illustrate that with a simple example, sorry, I'm on my touchpad right now, so it's a bit hard to control. Say we have a standard cube. Something like that. And each of these highlighted regions, if you can imagine just having these highlighted portions and not the stuff on the inside, that's kind of representing the 6 surfaces of a cube. And hopefully that concept makes sense. If you have any questions about that, please ask. If not, I'll introduce the first tool that you can use to create a surface. So the ones that Onshape has are pretty standard. You'll probably find them in other CAD programs, and you'll actually find usually that there are more options than perhaps what Onshape has. But offset is very standard. What you do, you have this drop-down menu. Maybe for you, if your monitor is wider, it just goes out to the right. But the first thing you have is what's called offset surface. Kind of looks like that. And what an offset surface does is somewhat similar to what a plane offset does, right? It creates a surface that is offset. And so for selection, you just select the face of a part. So in my case, I have this rectangular face of this part. And you select a distance, right? And what it does is it creates a surface, which is this, again, infinitely thin shape. and just kind of projects that a distance away from the face. So what I've created here, you can see in my bottom here, it's not a part like the solid object, but rather it's its own category, like a surface. And you might remember when we made helixes, that helix is also kind of reference geometry, not a surface, but it was more like a line. So here we have our own category for surfaces, and this is the first one. And so to demonstrate kind of the power of surfaces, you can imagine that making things with solid parts is in some cases a bit limiting, because a lot of objects that you have just commonly throughout your day aren't really made up of perfectly rectangular or cylindrical faces, which is what's really easy to make with extrude and revolve, which is our most common tools so far. But surfaces kind of fills up the other end, where you have all these objects that are more interestingly curved. So what I'm going to do is I'm going to create a cube. And this is something that we did like perhaps day one of the first CAD class. But instead of using the extrude tool, I'm going to use only surfaces. So this will hopefully illustrate kind of the difference between how the surface way of thinking works and how the solid way of thinking works. So I'll start off by making, as I usually do, a sketch with a square. And we're going to go into a different tool, which is the fill. So this is also a tool used to make surfaces, but unlike the offset surface, it works a little bit differently. So it's in the same place in your toolbar, but if you select fill, you can see this window comes up, and the way that you create a surface is by essentially selecting edges until you form a closed loop. So in my case, I have these square edges. I'll just select them and select them and select them. And like so, you can see what happens is I create my first surface. So down here, I don't have any parts, but I do have a surface. And it's this infinitesimally thin rectangle or square. So if you missed that, you can see this is how it works. I do have a lot of options for each one, but for now, just worry about the defaults. That'll work. Okay, so that's the first part of my cube. And the way I'm going to go about constructing this cube, instead of having a profile that I'm going to extrude through, I'm just going to create every surface that I can see of a cube until the entire cube is finished, right? So I have one of my 6 faces of a cube. Let's start working on some of my other ones. I know one of my other faces is going to be here. So I just drew another square kind of like that. And I'll do the same thing using the fill tool, the filled surface tool. And so again, I'll select edges, 1, 2, 3, 4. And once I select a closed loop, you can see it kind of fills in the color. And if I just select, it creates the surface. So now I have 2 surfaces in my surface section. I have this and this. So that's 2 out of 6 done. You can hopefully see where I'm starting to go with this. I'm going to create another one. And again, fill the surface. So already I'm halfway done with my cube. I have 3 of the 6 surfaces defined. And now I just need to do the other 3. So now I'm out of planes. Like I can't just draw here anymore, but what I can do is create some reference geometry. So that would be my planes. So I'll go in, I'll select my plane menu, and you can see I don't necessarily need to create an offset plane. I have some more options. So I'll show you another one that I have, which is, how about 3-point? So the way 3-point planes work is you select 3 points, and hopefully, as you know from geometry, 3 points fully define a unique plane. So I'll select the 3 points that I want, which are these. And you can see that hopefully Onshape is able to recognize that. You can see it created the plane right there. So what I'll do, I create my sketch on this little plane. Just constrain my sketch. And once again, just fill in that surface using the fill tool. So I have 1, 2, 3, 4, and that's another surface created. So that's 4 out of 6. Here's a better view. For my 5th one, I'll show you another way to make a plane. I guess I did show this before, but this is the line angle method. So just to have another view of it, that's the line angle tool. I want to select a line. I want to select a reference to start measuring my angle from. And from here, I know that every angle in a cube is 90 degrees. So I'll just put in 90 degrees. And you can see that my plane is created just where I want it, right there. And hopefully it'll let me select that plane. There you go. So now I can draw yet another square. And then fill it in using the fill tool. And finally, for this last one, I don't actually need to do anything because all the edges are defined for me. I've got 5 out of 6. And the last one is just based on these edges that are already in place. So I'll just make that. I'll change it to new just because. And finally, you can see that I've created my cube using surfaces. So right now, nothing is solid. I don't have any parts yet, as you can see on the left, but I do have 6 surfaces. And what I can do now is use this new tool called enclose. So let's say that you've had a set of surfaces that fully contain a volume with no gaps or breaks or holes. You can use the enclose tool. And if you select those surfaces that together enclose a volume, what you'll do, you can see that I just selected my 6 faces there. Once I do that, it turns those surfaces into a part. So now what I have is a cube. This is a solid object. It's exactly the same as if I'd done the extrude of a 1-inch square. But what this has done is I've created essentially a cube without using the extrude tool, just by defining all of these 6 surfaces. And so you might ask, why would I do this? Like, why would I ever do that and go through all that trouble when I could just extrude a square? Sometimes you run into shapes where the angles aren't 90 degrees. And so extrude is really great in cases like a cube where angles are 90 degrees, but that's not always the case. And so for one of the challenges this week, it's going to be some of these regular polyhedra. You'll see that a lot of these angles are not 90 degrees. And so using an extrude, it'd be really difficult to get some of this geometry. Something like this, even no matter how many extrudes and extrude cuts you make, it's going to be very difficult to create this kind of geometry. But using surfaces and using reference geometry, you have a lot more freedom and a lot more control over where things go. So a shape like this, I made this using only surfaces, and this is a solid object. You can see, just like any other part. I'll keep the feature tree hidden as to not spoil how you do it. But using the same principles that I just showed you, you can do something like that. So there's a lot of power there. If you have any questions, I'll pause for a moment to take them. I know I've been talking for a bit longer today than usual, but there's really a lot here. Next week, we'll be pretty much doing the same topic, just with slightly harder models. So you'll have another chance then to kind of absorb this, since it is pretty big topic. All right. So there are a few other things that you can do with surfaces that you might need for the challenge. One of them is to thicken a surface. So let me just create a surface really quickly, very easily, just by offsetting the surface. So let's say I have something like this. I have a surface and I want to turn this into a part. So I don't want like an infinitely thin, technically a zero thickness reference geometry. I want a part. What I can do is, in the same place where I have my enclose tool, I also have my thicken tool. And it does exactly what it sounds like. If you select the thicken tool, it pulls up this window. And if you select a face or a surface, it allows you to create essentially any kind of thin wall geometry from just a surface. And so perhaps if you choose this one, that might come in handy, where you want to create this shape where the walls are always orthogonal to the face itself. So I mean, what I mean by that is this and this are 90 degrees. I guess it won't let me select it, but this line segment and this plane are perpendicular. And so you can imagine, we'll go over sheet metal in a later class, but it's very similar to how sheet metal might work in real life. One more thing is you might be left with a surface if you use the thicken, where the surface, this reference geometry still exists. And let's say you don't want that. Perhaps you could hide it if you don't want. Another thing you can do is use this cool tool called delete. So this delete tool is very important in that it allows you to achieve something very basic, which is getting rid of something without actually getting rid of it. Let me just show you what it does. It says I can delete something. So let's say I delete surface 1. And it's just as if I had deleted it by hitting the delete key, except that it doesn't break the feature tree. Because you might recall that the thicken feature, it relies on that surface existing for it to exist. And so I can't just actually delete the surface, because then that would break everything below it in the feature tree that relies on it. But I can add this kind of pseudo delete, which will effectively delete my part without breaking any of the dependencies that I had before on that. So at this point, I'd recommend that you start looking at the challenges and start working on those. As usual for this week, I do want you to do 2 of them. So 1 in class, 1 for homework. If you do pick the polyhedra, I only really expect you to do 1, but if you do 1, I do want you to do it using surfaces and planes. rather than perhaps the easy way out. So you're free to do a cube, but I don't want you to just extrude a cube and be done. I do want you to try to practice using these surface tools. The tetrahedron we've also had before. So try doing it with planes. Octahedron is a new one. This one is perhaps like maybe the best difficulty level while still being a new thing. And this dodecahedron, this one I've attempted. It's completely doable, but if you do it, maybe you might need to look up some angles, which I had to do. It wasn't the easiest thing in the world, but if you use your feature patterns smart, it does save a lot of work. So I did use patterns for this one. And the icosahedron I've not attempted, and I'd only really recommend it if you're looking for spending several hours doing it. You can see it's fairly complex as a shape. So that's a very big challenge. Would not recommend for the casual modeler. But probably octahedron is the best to go out of these. For the banana, you have a lot more freedom. It's kind of like the pencil, where you have this perhaps swept shape, and then you have some lofts. I will say, as you go through this, loft has a few options that you might want to click through to kind of achieve these nice tangent curves. If you have a question about that, I'll be happy to talk about it. And this hopefully is straightforward enough. So in maybe 10 minutes, I'll come back and see how you're doing. If anything I said was I went too fast or I wasn't clear, I wasn't talking straight, always just let me know and I'll be happy to go over, demonstrate something again. So good luck. I will look for a battery for my mouse. And one thing you may find useful, if you're ever working in a plane that's angled such that it's not parallel to one of the coordinate axes, and that can be kind of annoying if you're working on a sketch and you can't really look at it properly, you can always right click on a face or a plane, and one of the options will be view normal to. Looks kind of like that. If you click that, it'll just adjust your view so that you're looking head on onto that. So even if it's at an angle, you can still look directly at it using view normal too. All right. Yeah. If you need to leave, same as usual. Try to finish one, I guess, today, and try to do another one by next week. Otherwise, same time, same day next week. All right, so in a couple more minutes, I'll ask people to share what they have. Again, don't be worried if you're just in the beginning. still sketching. Most of the challenge here is in the sketching, so we'll see how you're doing. All right, so I'll start calling on people alphabetically as I've been doing. Alex, would you mind sharing? All right, I like your use of surfaces, or planes rather. Yeah, seems like you're on the right path. Next, how about Alexu?
Oh, okay.
Yeah, don't worry if you don't have much.
This is my third attempt actually. So I made
Okay.
3-part studios and I made a square in these two, and this one I'm still not finished yet.
Okay, so are the other part studios just old attempts, like not using them, or are you trying to combine them somehow?
Well, like those are just attempts.
Okay, I see. Yeah, it can be tricky at first. Surfacing is definitely generally just a pretty advanced CAD topic where a lot of people end up not using them until very late, but it is very critical for a lot of applications. All right, next, how about Donna? All right, going for the dodecahedron, I see. It's very impressive. I see you're making your first plane there, which is good. That angle is actually not trivial. That might actually be the hardest part of this whole thing, that angle between those two planes. I can just tell you what it is. You'll have to type an equation into the field, but it just looks a bit complicated. It's not that hard to do. Just out of curiosity, what do you have as that angle right now?
I think it's 108.
Okay, yeah. So I believe 108 is the angle between adjacent edges or adjacent, yeah, edges. And so the plane angle is actually, you can imagine a trigonometric relation to kind of the projection of one of those edges. It ends up being this number, but you can just copy that into the Onshape number.
Wait, so that's the equation for like between the edges.
Between the faces, so to speak. So that plane, the way that it is right now, it would have to be at that angle that I just typed in, away from the bottom plane. And you'll observe once you, I assume perhaps you might use a circular pattern to make 5 faces at the same time. So when you do that circular pattern, you'll see the edges on adjacent faces might not line up unless you have this exact angle. I can kind of demo what it looks like at that stage. Yeah, so if you take a look, this is pretty much the same thing that you're doing. I have this first plane here, and you can see for the angle, I just typed in that exact equation. Hopefully if you just paste it, which I just did, it works. And it comes out to something like 116.6 degrees. So later when I make a pattern, you can see the edges actually match up perfectly, which is what you need. If you were to do a different angle, say 108 degrees, unfortunately, it does not quite line up. So it won't, I guess it might still close the shape once you're done, but I guess just to save you some time, I did end up looking up what the exact value was. Hopefully it makes sense why that angle is needed. Right, and that's kind of the reason why the icosahedron would be very difficult, because that angle, not just that angle, but how many patterns you'd have to do. But yeah, good luck, good choice. All right. Next, how about Luke Wang?
Can I have a couple minutes?
Yeah, that's fine. I can go back to you. Yes, Peyton said he is not here. So how about Selena? How are you doing? All right, I see first person doing the first one. And looks like got your planes going, so that's good. Yeah, and with the extrudes, that'll work. I'm sure you've already encountered the need for chamfers if you use the extrusion. So yeah, that'll work. Also consider that you could use like the surfaces and the thickening, which might make things a bit easier, but yeah, it looks like you're on a path that'll work. Yeah. Unfortunately, I don't see anyone who did the banana, which is always a fun one. I would recommend it maybe as a homework if you picked another one for this one. And maybe like as an extra motivation, being able to model a lot of these things are pretty helpful just as a repertoire. Maybe if you're applying for a team or maybe a job even that's related to CAD. It's always good to tell the interviewer some classic objects that you've done. Maybe the dodecahedron is fairly impressive. I know I'd be impressed if someone told me they'd made one of these. Banana is a classic one. Yeah, and on that note, just make sure to save your Onshape account and stuff. You never know when you might want to come back to these things. When it comes to the banana, I guess there's one thing I did gloss over, but for those who are interested, you can watch me do something. So let's say this is a thing that you can do with the loft tool. So the way you've used it before, you can usually just loft to two profiles, kind of like that. And so if I do this, you'll notice I get kind of this sharp edge, the sharp angle between my two profile lines. So let's say that I want this to be a smooth transition between these lines that I've highlighted. What I can do is Onshape is able to have different boundary conditions. So you can see these options. There are these drop-down menus, the start profile condition and the end profile condition. So the start is the first one you pick. In my case, it's the square. And one of these options is match tangent. And so when I click on that, what it does is it matches the tangent of the loft profile such that it's smooth with the shape that it's coming out of. So you can see now that these lines are pretty much exactly tangent, as a matter of fact. So when it comes to banana, it's something similar to that you probably want to do, just so that the curve looks nice from here to here. You can see it's very smooth.
I can share my thing now.
Yeah, sure, that'd be great. All right, is this the octahedron? Oh man, are you done?
Yeah. I made it kind of big.
Yeah, it looks good. I'm guessing you did, but what did you do? How about you tell me?
Okay. I just made a triangle here and then made a plane and then just made a dot on the plane, then
I see.
loft and then make this, then just mirrored it.
Yeah, it's pretty interesting. I wasn't sure, I didn't know actually in Onshape if you could loft to a point, but it's good to know that you can in terms of, I mean, yeah, that's very solid, very feature efficient way to do it. So nice work there. If you are up for it, try, I guess for the homework, maybe try doing it with the new surfacing or plane tools. Just get a bit of practice with those, but the essential shape looks good there. And so as we're approaching the end of the class, not just this class, but the whole class, just to give an idea of how we're ending, next week we'll be doing some more stuff with surfaces. So not too much new topics perhaps, but we will be trying to do some more complex objects. So right now what I have planned maybe is like a computer mouse for one of them. We'll see if I manage to make a good one as an example. It's more interesting, more intricate shapes that hopefully reveal to you more of how common products are designed. In the last class, we'll go over some sheet metal stuff, which should hopefully be interesting. If you do want to make like a request of a topic to cover, I'd also be willing to take that maybe in the last class. So starting now, just think about anything that you'd want to learn how to do in CAD. It doesn't have to be some specific tool or technique, but just generally like, how do I do this? How do I do that? If you ask a question, I could look into it between classes. But otherwise, I did make the classroom assignments. So whenever you're ready, just submit the class one. And by next week, the homework one. I'm fine with a link to the Onshape document or an image or a step file, whichever is more convenient at this point. I imagine most of them will look fairly similar, except maybe the banana. So in the last few minutes, just open floor to questions. Can be about previous weeks as well, if you have them. All right, since it seems like there's no questions, I look forward to seeing your submissions as usual. I might start putting them on the slides again since everyone's not doing the exact same thing. And otherwise, I'll see you next week. Same time, same day.
Thank you.